In this question, we are writing a balanced thermochemical equation for the complete combustion of butane. Complete combustion suggests that we are going to be producing carbon dioxide and water. And generally for these equations, this is conducted at SLC. So that means the state of water needs to be in the liquid state. We're going to then need to balance our equation. So balance the carbons first, followed by hydrogens and then oxygens. So your equation should therefore look something along the lines of this. Because it's a thermochemical equation, we need to actually state what the enthalpy change is. Given that the coefficient of our equation is 1, we can simply just copy down what the delta H value is from the data booklet. So therefore, I'm going to be writing the delta H value as shown here. And notice that the units is going to be kilojoules per mole when the coefficient is 1. However, some of you may have doubled the equation, which is fine. So if you've doubled the equation, make sure you've also doubled the delta H value. However, if you do this, the units is just going to be kilojoules rather than kilojoules per mole. In part B of this question, we are finding out what is the amount of heat energy absorbed by water. So we're going to need to use the QMAP formula. They haven't given us what the mass of water is directly. Rather, you will need to calculate the mass of water. So they've given us these two values over here. We're simply just going to have to subtract those two values to find out the mass of water only. So the mass of water is going to be 251.23 grams. They've also given us what the change in temperature is. So if you plug all these values into the QMAP formula, just note again that your answer is going to be in joules. So it'll be 11,131 joules. The question does ask to express your answer in kilojoules, so divide that by 1,000, and in doing so, you'll get the following answer when corrected to 3 significant figures. In part C, we are trying to calculate the molar heat of combustion of butane. So that means what we are going to be using the formula delta H is equal to Q over N. From the previous question, we've already calculated what was the amount of energy absorbed by water. In this particular question here, we're assuming that all of the energy that is absorbed by water is the same amount of energy that is released from the combustion of butane. So all we really need to do now is just calculate the number of the number of moles of butane that has reacted. In this question over here, they have told us what the starting mass of butane is and the final mass of butane following combustion. So what we're going to do is we're going to subtract the difference between this to find out how much butane has reacted. That's equivalent to 0.36 grams. Then we're going to go mass divided by molar mass and simply then substitute the Q value along with our N value into the formula. And this will give us an answer of 1.8 times 10 to the power of 3 kilojoules per mole when corrected to 2 sig figs, as this over here is given in 2 sig figs.